Okay, so some people have already looked at the board and they're aware of what indices are. So if you don't need to remind yourself what an index is, don't bother writing it. But I've told you from the start that I'm never going to be that guy that goes, you should have known this. It's a bit rich for me to go, you need to know the indexes, so that I'm just going to teach you from here. Let me remind you what an index is first. An index, indices for multiple. Does anyone know what the other term for indices are? Starting with a P? Power. What is the other term that starts with an E? Exponent, well done. Numbers written in superscript. So small writing above right of a particular base. The base number is written as normal text size. So here, the base number is normal size. The power is top right. In smaller writing, what does this mean? This means that the base number 2 is multiplied by itself how many times? 3. 2 times 2 times 2 is 8. We can perform operations between numbers that have powers like this, but do you agree that this is a waste of time? 6 to the power of 5 is 6 times 6 times 6 times 6 times 6, and then I'm timesing it by that. Thus, we have index laws. So hopefully you see why I tell this story. We have this because this is not a useful thing, okay? So these are the index laws. This is probably what should go onto your cheat sheet. The index laws are rules that apply to situations that involve powers. If A and B are base numbers, then if I'm multiplying the same base number but different powers, what do I do with those powers according to this rule? Add them together. So, to apply that, do I have the same base numbers here? Yes. Are they both x? So, and then you check, am I multiplying them? So the answer is going to be x to the power of 6 plus 3, 9. The next index law. I'll go through these laws and then I'll pause so you can get them down. Here you're dividing instead. Same base number, dividing different powers. What do I do with those powers now? Someone else? What does that say? You take the powers instead. So, do I have the same base number here? 3. I'm dividing, so I'm going to take the powers. So it's going to be 3 to the power of, can I actually take 2 from x? Do I know what the answer to that is? So you write it as x take 2. You can leave it in brackets as well, because I can't work out what the answer to x take 2 is. Here, I have a base number with a power, and then that itself is risen to a power. What is this telling me that I do with those powers? What is the multiply? The sign in algebra that we do not write is multiplication. So if it says mn, I'm timesing m by n. So here, you're probably telling me, what have you been smoking, Mr. Twazon? That's a base number to a power. Aren't you supposed to be showing me a number raised to a power, then raised to a power again? Is there a number that I... Good. So, she's seen that it is this situation. 9 is 3 squared. 3 squared to the power of 4. And then according to this rule, what do we do with those powers? You times them. So it's going to be 3 to the power of 8. This one here, I always use the meme. If you watch the videos on the playlist, I always use the meme like saying it's like COVID. If you've got two numbers multiplied by each other in the brackets, raised to a power, that power spreads. It spreads to both. Okay? So, what is the sign between 2 and x in these brackets? Multiplication. So we have this situation. So what happens to that 3 power? It spreads like COVID. So we end up with 2 to the power of 3 times by x to the power of, what's x going to be raised to? 3. 3 as well. Now that is the answer, but you're not going to get full marks for that, because is there anything stopping you working out what 2 to the power of 3 is? No? So please make sure you simplify as much as possible. 2 to the 3 is 8 x to the power of 3. This, give you some time. If you need it on your cheat sheet, go fill up. Don't talk too much, it's still recording. when you're doing there's a booklet already on Daymap for it. When you're doing the practice, I'll go through your test individually. I'll call you out, yeah? Yeah. Watch out for the ghost cheeks. They're going to get you.
Can I move this? Or is that still?
Actually, no. It's already on the video. It's already on the video. People need to copy it down. Because I just want to finish off the remaining index laws. This one here, much like multiplying, you're dividing A and B. What does the power do? Spreads like crazy. So that A divided by B, all to the power of n. What do we end up with? A to the power of n over B to the power of n. So here, these examples I'm loading up a little bit. What is that 4 power going to do to this 3c? It's going to spread to it. So it's going to be 3c to the power of 4 over b to the power of 4. But now we have another law that has to apply to this. I have 3 times by c. What is that 4 power going to do to the 3? Spread to it. So that's still going to simplify. That's going to be 3 to the power of 4 and c to the power of 4 over b to the power of 4. That's close, but you're not going to get full marks because there is nothing stopping you working out what 3 to the power of 4 is. 3 times 3, 9. Times 3. What's that? 27. Oh, no. 3 times 3, 9. Times 3, 27. Times 3. 81. 81c to the 4 over b to the 4. The next law, just memorize it, please. Anything to the power of 0 is 1. As long as the thing, the base number, is not 0 already. Because 0 to the power of 0 would be, I don't know if you can do that. Is that legal? No idea. 4 to the power of 0 is going to be 1. Anything to the power of 0 will be 1. This is the one, this law here is the one that I like to spend a little longer time on, reciprocals. So, if you have a fraction to a negative power, what do you notice happened to that fraction when the negative was dealt with? It flipped. So a negative power is the reciprocal of it, which is the number flipped. And then that power applies to both. So if I had this, 3 to the power of negative 2. You're going to be telling me, Mr. T, what you've been smoking. 3 is not a fraction. Yes, it is. It's just not written as. Excellent. 3 to the negative 2 is actually 3 over 1 to the negative 2. Now let's deal with a negative power. What does the negative do to it? Flip it. So now that's going to be 1 over 3, but it's still to the power of 2. So it's going to be 1 to the 2, 3 to the 2, so 1 to the 2 is going to be 1 over 9. And then this one here, this one's actually easy. So how do I deal with a negative? Flip it. 3 over 2, and it's all going to be squared. 3 squared over 2 squared. 3 times 3, 9 over 4. Is there any cancelling down that I can do of 9 over 4? No, they're not even numbers. So this is a challenge one. This lesson, literally, if you look at my 10 extension maths playlist, this is how I teach it. Let's see, Eric, no. Let's see applying all of those rules all in one. Is 20 being raised to a power here at all? No, it's not part of the brackets, so it stays at 20. Do I have a rule that applies to something raised to a power again? Yep. What happens to that?
Those 2 two powers times together.
Good. So it's going to be x to the 18. Good. Over. Is 5 being powered at all? It's not in the brackets, so no. But do I have a similar situation as above? So it's going to be x to the 2 times 7, 14. Now we can do something here. Is there anything stopping me from working out what 20 divided by 5 is? So that's going to be 4. But now we have same base number. These are same base number, x. And do they have powers?
Yeah.
What do I do when you're dividing? Same minus. So it's going to be 4 times by x to the power of 4. And there's no more cancelling that I can do here. That's index laws. Done? I'll stop the recording. You're doing, I think it's 1C on the timer.